Hello everyone, I'm Anand and I'm going to present diaphragm wall constructions for deep foundation. It's a presentation on the case study which happened in Sri Lanka and India. The outline of my presentation includes introduction, application, methodology, conclusion and references. The retaining wall is a structural wall which resists the lateral pressure caused by water, soil or anything else. In the picture shown here on above, I have shown the picture where water is causing the lateral pressure on the retaining wall. Now we have three kind of retaining walls normally used in constructions. One is cofferdam shown here on the left side, diaphragm wall this one, and then we have a secant pile wall which is this one. The cofferdam is used normally in offshore structures where have a lot of water nearby. Diaphragm wall and secant pile wall construction is done on the ground. Application. Do I need a retaining wall always for deep excavation? No, you don't. Because if you look at the picture here, the first one on the left side, I don't have a retaining wall. This is the main excavation area for the foundations and you do not see a retaining wall. That is because the soil which is experiencing the lateral pressure is the weight of the soil and the groundwater table. It does not have any structures nearby. And to lower the groundwater table, the hydraulic pumps are installed on the periphery, as you can see this one, you can see here. So you lower the groundwater table, that reduces the lateral pressure caused by water, and then the only pressure which is there is soil weight or pressure because of the soil. And if the soil is good enough, then you don't even need a retaining wall. And I have so much space here. As my foundation is happening here, I have the liability of space. I don't need a retaining wall. On the second side, on the right hand, you can see I have structures nearby. I cannot just excavate. All the soil will pour in and there will be big settlement and could be lead to an accident as well. So you need a diaphragm wall or retaining wall to the excavation. Why diaphragm wall? Why can't I use secant pile wall as a retaining wall? You can, but diaphragm wall has its own advantages. So normally in cities where I have congested area, it can be done very easily. It is very suitable for deep foundations. It is done with top-down construction method, which is very common. It can be done in fast. It is very strong and watertight, so you don't have problem of water leakage as well. And since it's normally reinforced concrete wall, you always have the variation in strength. You can go from lower strength to very high strength based on the requirement. So you have the range in which you can operate, which is always good. You don't want to waste too much money on that as well. And then the best of it is no vibration during installation, which happen in the secant pile wall. And when you are in city, you cannot just do all the vibrations. How we are going to proceed for this methodology is that first site investigations, which is called preliminary study, then construction process, post behavior analysis. Site investigations or preliminary study involves the study of the site, which is basically you want to know what kind of soil it is inside, what is the soil profile when you go deep, where is the bedrock, where is the groundwater table, what are the structural load the soil is experiencing, are there any nearby water bodies or structures. You dig the borehole, you take the soil samples, you take the undisturbed and disturbed sample of the soil, and then you do the testing on the site and in the lab as well. This is done to give you basic idea or to choose what kind of diaphragm wall you need, what material you're gonna use. Normally we have three kind of diaphragm wall. One is RCC, second is precast, third is normal concrete based on the strength. Now the construction process. The diaphragm wall constructions happen in many steps, and the first step is to know where you're going to construct your diaphragm wall. For that, you have to have a guide wall. Now the guide wall's objective is to fix the alignment, to give you an idea or the instrument. You can see the crane here, to give this crane instrument an alignment where it has to go deep, how deep it has to go. So that guidance is given by guide wall as it mentions. As you can see in this picture here, this is my guide wall, which is nearly 1.5 meter deep, and you dug a trench and you construct RCC wall vertically. So it's made of normally RCC or just concrete. It provides spot for trenching. Trenching is like excavation. So if you can see here, I have the guide wall throughout the length of the diaphragm wall, which I'm going to construct. Then I have the excavation tool or instrument, which lowers in the guide wall and excavates a panel. You do not excavate all the wall in one go. You excavate it by panel by panel. So you excavate the first panel, which is like trenching process. You excavate one panel. When you excavate it, based on the groundwater level, water might seep in from the sides, soil might fall inside. To avoid this kind of problem, we use bentonite slurry from silos. You insert bentonite slurry in the trench or in the panel, same time you're doing the excavations. Once that is done, the whole panel is filled with bentonite slurry. You install called stop ends. You install one here, one on the other side. That is to avoid water seepage, and that is watertight. Now, you sometime if you have some space, you can lower the groundwater level, which can reduce your problem in terms of taking the water out of it. So if I have some space, or nearly 5-6 meters of space here, I can dig a borehole, lower the groundwater of this level of this area, and then I can do the excavations. Depending on the where you are, sometime you don't have space for drilling the borehole, sometime you have. So anyway, if you don't have the space, you use the pump to take the water out of the panel directly, and then insert the bentonite slurry. Yes, after you have the slurry done, you want to do the reinforcement installations. So reinforcement is made or assembled on the site itself, where you can see I have longitudinal bars and lateral bars. This is done normally to resist the longitudinal and lateral pressure. And as you can see in both in the center, these hollow pipes, solid hollow pipes, this is the pipe you can see here as well. This is used for post-analysis behavior of the diaphragm wall, which I'm going to talk later on. So you lift it with the crane, then insert it lower down in one panel. As you can see in this picture, I have put the case, and once the case, you have put the reinforcement case, you want to pour the concrete. Now the concrete which is poured is self-consolidating concrete, because you don't have the vibrator which will go down and vibrate the concrete based on the reinforcement of density. So you want self-consolidating concrete which moves through the rebars, consolidate well, watertight, become very dense, and then it can help you in high density, high early strength, and improve the quality of your wall. Now you want your concrete to be high early strength. That is because after one panel is done, you want to move to the next panel and remove this soap stopper. So these stops and stoppers are there, which you will remove after you put all the concrete. Normally concrete has high density, so once you pour the concrete using this particular space, the bentonite slurry which is inside is poured out or taken out in silos back to the silos with a pump, and that slurry is used again after filtration for the second panel excavation. Now once you have all the panel done, you have the wall ready. So this is the wall. After the wall, you want to do the anchoring and pre-stressing based on the requirement. And how that is done is you have the cylindrical element which is hollow, and it's bored inside the wall deep into the soil. So it always has the connections to the soil and the wall. And then you insert these steel strands which is shown here, reinforcement strands, and then pour the grout. Grout is a cement with water and some chemicals. It's very fluidy, so very easy to pour in, and it hardens and it fills all the pores inside the hollow cylindrical element and the strands. It stops the corrosion of the strands, which is very big issues when you do the anchoring. And since I have the cement grout as a cover, the strands don't get corroded so easily. And after that, the strands are pulled out using this particular mechanism. When the strands are pulled, my concrete wall is in compression and my strengths are in tension, and we all know concrete is very good in compression and steel is good in tension, and that's why we do the pre-stressing. Now to summarize the construction process, which is basically is using the first construction of guide wall, then excavation of one panel using bentonite slurry to make sure the soil does not collapse, inserting the rebar cage, and then pouring the concrete, taking the bentonite slurry out, putting the bentonite slurry back in the second panel, do the second panel excavation, then third panel, similar fashion you would do the excavation of all diaphragm wall and installation of concrete, reinforcement concrete in that. Now the post behavior analysis, as I mentioned before, when you have reinforcement cage, you have the hollow pipes installed. This is the diameter of the pipe, and you can see I have strain gauges and inclinometer installed in that. You can see the person putting inclinometer in that. Inclinometer will give you inclination angle of the diaphragm wall, which is caused by lateral pressure due to the nearby soil, water, and the structure. Now you will always have some deformation, but how much is the deformation, that plays very crucial role. Now based on your structural requirement, you know how much deformations you have to be limit with, and you do the analysis. And as you can see the left picture here, I have the zero displacement, and as the depth goes more, you go more down with the depth of the wall is I think nearly 35 meters. You can see the deformation to 22 or 25 mm when you have depth of 20 meters. So this is within the range as it's specified. This monitoring can be done on weekly basis, on a monthly basis as it's required based on your requirement. So normally you can always monitor it because you have the hollow pipe, you have the inclinometer inside it, you have strain gauge, you can monitor it for years as well. And based once you have the enough data, you can do the FEM model to predict the behavior and to see how your wall is going to behave on later stage, how much it's going to deform, and these all are used to optimize the process, to have a better understanding of what material and what kind of quality wall you need for particular strength, and to further to reduce the cost and better behavior analysis. Conclusion: why diaphragm wall? Because it is low cost, it's easy to install, the process is very quick, it's effective in all sort of soil type, stable, unstable, it's very durable, it can go 50 meter deep or high, very stable method, people are using from like years, and you can always do the post behavior analysis. These case study references are China, Chennai Metro Construction in India, Sri Lanka Apartments in Colombo, and that's all. Thank you very much for your time. Bye.